Welcome back, students. Today we are going to discuss about certain numerical problems based on equations of motion. In the last session we have covered the topic equations of motion, and today we are going to discuss certain numerical problems based on that. So let us move on to the first problem, and for the question you may please refer your NCERT science textbook. Moving on to the textual exercise questions, that is there in page number 144, question number 13. Page 144, question number 13. Question is, a ball is thrown vertically upwards with a velocity of 49 meter per second. Calculate subdivision 1, the maximum height to which it rises, subdivision 2, the total time it takes to return to the surface of the earth, and subdivision 3, only subdivision 2, only up to subdivision 2. So, you need to find the maximum time and the total time taken to return back to the surface of earth. Now, let us write the given quantities first. So, in the question, a ball is thrown vertically upward with a velocity of 49 meter per second. So, it is thrown with an initial velocity 49 meter per second, and the ball is moved upward. When a ball moves upward, when an object moves upwards, its velocity will decrease. Its velocity will decrease, and at maximum height, the velocity of the object will be equal to 0. Initially, the object had a velocity u is equal to 49 meter per second. As the object moves up, its velocity will decrease, and finally when it reaches the maximum height, its velocity will become 0. And here, since it is moving up and its velocity will decrease as it ascends, acceleration of the body will be equal to acceleration due to gravity and will have a negative sign since it is moving upwards. So, g will have a negative sign. So, value of g will be minus 9.8 meter per second square. Okay. So, these are the values given in the question, and first subdivision is to find the maximum height to which it rises. So, you need to find height or the distance. S is equal to, you have the equation. So, you need to find S. Again we have the equation v square minus u square is equal to 2gs, our third equation of motion. V is given, u is given in the question, g, the value of g is known, we need to find s. That is, let us substitute the values. V is 0 minus u square is 49 square is equal to 2 into negative 9.8, g is negative 9.8 into s, that is minus 49 into 49 square is 49 into 49 is equal to minus 2 into 9.8 s. Minus and minus sign gets cancelled off. Already we have 49 into 49 here. Take this 2 into 9.8 to the other side. So, here it is into. So, when it moves to the other side, to the left hand side, becomes deviation, that is 2 into 9.8 is equal to S. On solving this, you will get the answer as S is equal to, on simplifying this, you will get S as 122.5 meters. 122.5 meters. So, this is the maximum height to which the body rises. Now, moving on to subdivision 2, the question is to find the total time it takes to return back to the surface of earth. Okay, the total time needed to return back to the surface of earth. So, initially the object has to move upwards. Let the time taken for that be t1. After reaching a maximum height, the object will return back following the same path and reach down. Let that time be t2. Since the object is following the same path and the acceleration of the object is completely due to acceleration due to gravity, this t1 will be equal to t2. t1 will be equal to t2 and the total time taken to reach back the ground. Total time taken to reach back the ground is t1 plus t2. From ground to the maximum height, it needs to take t1 seconds, and from the maximum height to reach back the ground, the object needs t2 seconds. The total time is t1 plus t2, and here both t1 and t2 are the same since the object is following the same path and acceleration of the object is completely due to gravity. Both the time taken will be the same. Okay. Now, let us move on to the question. We have the equation V is equal to U plus GT, which connects velocity, acceleration and time. So, from this equation we can easily calculate T. We know value of V is 0. Now, we are finding time T1 for the object to reach maximum height. So, when the object reaches a maximum height, the final velocity is 0 plus initial velocity is already given as 49 meter per second plus the object is moving upwards. So, G will have a minus value, that is minus 9.8 into T1. The time taken for the body to reach the maximum height, that is 0 is equal to 49 minus 9.8 T1. Now, take this minus 9.8 T1 to the other side. So, when this minus term moves to the left hand side, it becomes positive. So, it becomes 9.8 T1 is equal to 49. So, T1 is equal to 49 by 9.8. 49 by 9.8, and on simplifying it, you will get the answer as T1 is equal to 5 seconds. And this is the time taken for the body to reach a height. Again, to come back, again it takes a time of 5 seconds itself. To come back to ground, again it takes a time of 5 seconds. Therefore, total time taken to reach back the ground is T1 plus T2 is equal to 5 seconds plus 5 seconds is equal to 10 seconds. This is the total time needed for a body to reach back the ground. Hope the problem is clear. Now, moving to the 14th question of your textual exercise. That is page number 144, question number 14. Page number 144, question number 14. The question is, a stone is released from the top of a tower of height 19.6 meters. Calculate its final velocity just before touching the ground. So, here a stone is released from the top of a tower. So, a stone is released from a height. So, initial velocity is 0 meter per second because it is released from a height and it is descending down. So it is descending, since it is descending down, its velocity will increase. So initially the velocity was minimum, that is 0. When the object is at a height, velocity is 0. It descends down from a height of 19.6 meter. So the height covered by the object is 19.6 meters. Calculate its final velocity just before touching the ground. You need to calculate the final velocity v. Here the body is descending down. So as a body descends down, its velocity will increase and acceleration of the body will be equal to acceleration due to gravity and will have a positive sign since the body is moving down. So which is equal to 9.8 meter per second square. And we need to calculate v. We can calculate, so u, s and g is given, you need to calculate v. The equation connecting all these quantities are v square is v square minus u square is equal to 2gs. V is what we need to find, value of u is given, value of g is given and value of s is also given in the question. By substituting the given values, we can easily find v. That is v square minus 0 is equal to 2 into 9.8 into 19.6. That is v square is equal to 2 into 9.8 into 19.6. So v will be equal to, to solve v, take the square root, that is 2 into 9.8 into 19.6. Take the square root and get the answer for v, and the unit of v will be in meter per second. On taking the square root, you will get the answer for final velocity v in the unit meter per second. Okay, simple and direct problem. Now moving on to question number 15. Again on page number 144, refer question number 15. Question is, a stone is thrown vertically upward. So it is thrown vertically upward. When an object is thrown vertically upward, its velocity will decrease while the object ascends. And acceleration of the body will be equal to acceleration due to gravity and will have a negative sign since the body is moving upwards. Continue reading the question. With an initial velocity of 40 meter per second. So the initial velocity of the body is 40 meter per second. Taking g is equal to 10 meter per second square. So the question, g is given as 10 meter per second square. Since the body is ascending up, it will have a negative sign. The value of g will have a negative sign. Find the maximum height reached by the stone. So you need to find the maximum height reached by the stone. Find the net displacement and the total distance covered. So you need to find both displacement and distance. So you need to find here the height covered, the displacement and the distance, and these are the given quantities. Since the body is moving upward and when the body reaches a maximum height, when a body moves upwards, initially it had a velocity u is equal to 40 meter per second. As the body moves up, its velocity will decrease, and at maximum height, when a body reaches maximum height, the final velocity will become its velocity decreases, and finally when it reaches maximum height it becomes 0 meter per second. So V is 0 meter per second. So you have V, U and G value and need to find S. Again the equation connecting all these quantities are V square minus U square is equal to 2GS. Now substitute the given values. V is 0 minus U square is 40 square is equal to 2 into G is minus 10 into S is what you need to find. That is minus 40 square, that is 40 into 40 is equal to, here also you have a minus, take it outside, 2 into 10 is 20s. Minus and minus will get cancels off, remaining is 40 into 40 is equal to 20s. Now place S over here, bring this 20 to the other side. So here it was 20 into S. So when it moved to left hand side, it becomes divide by 20. And the answer of S is, on solving this, you will get S as 80 meters. On solving this, you will get the answer as S is equal to 80 meters. Using the equation V square minus U square is equal to 2GS. Okay. Now, the next subdivision is to find the displacement. You need to find net displacement of the body. Okay. So, a body is thrown up, it reached the maximum height. Will the body stay over there? No. The body will definitely come down after that trip. So, when a body is thrown upwards, it will reach a maximum height. After reaching a maximum height, it will definitely come down. So, this is the initial point from where the body started. After reaching a maximum height, the body will follow the same path and comes down and reaches the initial point itself. So, here the initial and final points are the same. Initial point and final point of the body are the same. Since initial and final points are the same, net displacement will be equal to 0. What you have learned in the chapter 1, motion. If initial and final point of an object are the same, then net displacement will be equal to 0. Now, the total distance covered, next subdivision you need to find is the total distance covered by the body. The body covered a 80 meter distance to move up. So, to move up, the body covered a distance of 80 meter. After reaching a height, the body will come back to ground, again covering a 80 meter distance. Okay. So, the total distance will be, to move up, the body covered a distance of 80 meter. After reaching a maximum height, the body will come down and falls back to ground, again covering a distance of 80 meter itself. So, total distance will be equal to 160 meters. 160 meters. Okay. Hope the question is clear. Now, moving to question number 18 of your textual exercise, which is there in page number 144. So, next question, page number 144, question number 18. Question is, a ball thrown up vertically returns to the tower after 6 seconds. So, a ball is thrown up, it reaches a height and then returns back to ground. And the total time taken for that, is 6 seconds. Total time, that is In order for the ball to move up, let the time taken be t1. And after reaching a maximum height, the ball will move back to the ground. Let that time be t2. So total time will be t1 plus t2. It is given as 6 seconds. Okay. So what will be t1? Here also the body is under free fall. So acceleration of the body will be equal to acceleration due to gravity, and the body moves up and it follows the same straight line path to reach back the ground. So to reach back the ground, the body will follow the same path. So T1 will be equal to T2, which is equal to 6 seconds by 2. Okay, which is equal to 6 seconds by 2. So time taken for the body to move up, will be 6 seconds by 2 is equal to 3 seconds. Okay. Now find subdivision A, the velocity with which it was thrown up. So you need to find the velocity with which it is thrown up. When a body reaches maximum height, when a body moves up, its velocity will decrease, and when it attains a maximum height, its velocity decreases and finally becomes 0 meter per second. And since the velocity is decreasing, acceleration of the body will be equal to acceleration due to gravity and will be having a negative sign. So it is equal to negative 9.8 meter per second square. The time taken for that is, from the ground to reach the maximum height, it took a time of 3 seconds. So V, A and T is given. You need to calculate the initial velocity. You can easily calculate the initial velocity using the equation V is equal to U plus GT. V is 0, U is what you need to find, plus G is minus 9.8 into 3. Time is 3 seconds. Now take this minus 9.8 into 3 to the other side. When minus sign moves to left hand side, becomes positive. So 9.8 into 3 is equal to U, and on solving that you will get the answer as U is equal to 29.4 meter per second. 29.4 meter per second. Now that is the value for initial velocity. Now subdivision 2 is find the maximum height it reaches. So you need to calculate the maximum height. Maximum height it reaches. You have the formula to find S as ut plus half gt square. Substitute the values. U is initial velocity. We have already found it as 29.4 meter per second. So U is 29.4 into, to reach a height the time taken is 3 seconds, plus half into, the ball is thrown upwards. So G will have a negative value. So G is minus 9.8 into T square is 3 square. That is 29.4 into 3 plus into minus is minus half into 9.8 into 3 square is 3 into 3. 3 into 3. 29.4 into 3 is 117.6. When you multiply this, you will get the answer as 117.6 minus, when you solve this second term, you will get the answer as 78.4. When you subtract 117.6 and 78.4, you will get the answer of S as 39.2 meters. On subtracting, you will get the answer of S as 39.2 meters. That is subdivision. Sorry. On simplifying this, multiply 29.4 into 3, multiply the second term and subtract both. On simplifying, you will get the answer as 44.1 meters. On subtracting and simplifying it, you will get the answer as 44.1 meters. Now, third subdivision is find its position after 4 seconds. Find its position after 4 seconds. Again, you can use the same equation to find the position. S is equal to ut plus half gt square. That is, u is 29.4 into time is given as 4 seconds. So, instead of time, substitute 4 plus half into minus 9.8 into time is 4 square. That is 29.4 into 4 plus into minus, it is minus half into 9.8 into 4 square is 4 into 4. Simplify both the terms and subtract it. You will get the answer as 39.2 meters. On simplifying and subtracting it, you will get the answer as 39.2 meters. Okay. So, these are the certain problems based on equations of motion. V is equal to u plus gt, S is equal to ut plus half gt square, and v square minus u square is equal to 2gs. Steps are completely similar to the problems that we did in the first chapter, motion. Only thing is, instead of A, we need to substitute acceleration due to gravity, g. And when a body moves up, acceleration due to gravity will be negative, and when a body moves down, acceleration due to gravity will be positive. And when a body reaches maximum height, its velocity will be 0. So, these are the some points to be remembered while you do the problem. The remaining part, the solving part, is completely similar to the problems that we have done in the first chapter. Hope the problems are clear. Please write and learn the problems. Thank you.